and strain related through a constant coefficient means that that constant coefficient is the Young's modulus. So this thing is not cooperating. So my Young's modulus for this laminate is given by this quantity, which involves directly the A matrix. And you can also show that the quantity here in brackets is actually the 1 over little a11. So the inverse of the A matrix involves this little a11 term. And you might say, how do you know? Let's see if I can remember my matrix manipulation. So I have my A matrix is A11, A12, 0. For the case of a balanced laminate. So if I want to invert this, let's see. Let me move here to the right. Now I claim, because this is a symmetric matrix, the inverse of this will have this term to be 1 over A66. The zeros will stay where they are. And then all I have to do is invert this guy. And to invert this guy, I need to calculate the determinant, which is the determinant of the 2 by 2 only, A11, A22 minus A12 squared. And then I take this term and put it there. So it's A22 delta. This is minus A12 divided by determinant. I'm sorry, let's not call it delta because it gets confused with the discriminant. And then it's symmetric, minus A12 over the determinant and A22 over the determinant. Now I know that these days you just ask Maple to do it for you, but to at least convince you that this might be the correct one. That means now this term here is my little A11. Because by definition we said the inverse of the A matrix is the little A matrix. So A11 is A22 over this determinant, which hopefully is the same as I wrote there. A11 is A22 divided by this determinant here. So I can either write my stiffness in terms of the capital A matrix or in terms of the little a matrix, which is what most people do. So stress relates to strain through this coefficient of proportionality, which is my stiffness 1m. 1m is important, even though you can use any symbols you like. 1 is the direction in which this is acting. So for our laminate there, it would correspond to a load applied in this direction and a strain measured in that same direction. Then the stiffness that we would get, or the Young's modulus we would get, would be that one. And this is not the same as the stiffness in any other direction in the laminate. So that's why we have to differentiate, or at least indicate in what direction. There's also a subscript m, which is for membrane, which means that this is for in-plane loads and pure in-plane strains. Because if you bend the structure, the Young's modulus you would measure is not necessarily the same as we are about to see. So far with me? Okay. So the same way that we did this for the one direction, you can do it for the two direction, and you will see the analogy directly. And for the G12, which is the shear modulus for in-plane shearing of that laminate. And then you have the two Poisson's ratios. This is loading in one direction and measuring the transverse contraction in the two direction, and the bottom left here is loading in the two direction and measuring the transverse contraction. Make sure you keep in mind that these two Poisson's ratios, nu12m and nu21m, are not necessarily the same. in general, they will not be the same. Now, this is the left column on this page. The right column said, well, what if instead of having pure stretching, you have pure bending? So you would get different expressions, which now involve the D matrix, the little D matrix shown here at the denominators, and those will very rarely be the same as the membrane ones. So it's important to keep that in mind. We will see that again in much more detail when we talk about buckling of beams and so on. But there's a membrane set of stiffness values and a bending set of stiffness values, and they are in general different. And you have to decide in advance which are the ones that are operative for your problem, and use the correct ones, or if you don't know for sure, use the ones that would give you conservative results. We will see cases later on where it's actually not even obvious what you should use, and it's up to you. Some people use the average, some people use, or most people use the most conservative.